All right. So we're going to present SQL and NoSQL injections. Um, and so to start off with, we're going to do a basic introduction on what exactly SQL is and what it's used for. So to understand SQL, it's important to note that it's used to work with databases, and more precisely, it's used to manage relational databases. Relational databases are databases that are structured using tables that are linked amongst each other. On the side, for example, we have an accounts table where each user has a username and a password, but each username and password is also linked to a piece of the user table with the user information. So you can see there's different tables linked together. And SQL, short for structured query language, um, allows us to access these databases and to navigate them using queries, which are carefully constructed to specifically find data in the databases. And as we'll see later, this structure can be easily taken advantage of with SQL injections. So it's to be able to do SQL injections, you got to understand SQL statements which use queries. So these statements are essentially commands that are formulated to directly access a database. So to make a specific action, a query statement has to be built. The basic format of these statements is with the query select, from, and where. Select is used to give the name of the fields you are looking for. From is used to pick out the table you want to get information from, and where is used to apply conditions to the statement. For example, where password is equal to a specific value. It's also important to note that if you see select and then star, it's equivalent to select all, as in it will select all the fields that are pertinent. And so these queries here are used for the most part to retrieve data. Although there are other queries like insert and alter table and delete that are used to modify the database directly, which can also be used for SQL injections, but we're not going to look at that as much. So here's a quick example on how exactly SQL works to access a database from a simple login page. So as you can see, the login form asks you for a username and a password. And when you input like cyber and kiwi into these fields, it's going to be used to directly construct the SQL statement that accesses the database to find your user information that matches what you input. So when you put cyber in the user box, the user variable is set to cyber, and the same with password. So the login's job essentially is to find your account that matches cyber and kiwi in the accounts table. And so what it does is it translates this input into a SQL statement that's going to look something like this. Select all. It's going to select everything from the row from accounts. Accounts is the table we saw on the page before that has all the user information, where username is, and then here it's going to take your input directly that you put in the user part and put it as the condition for username, and the same with password. And so when you put it all together, it'll do select all from accounts where username equals cyber and password equals kiwi. And using this query, it'll be able to directly find your account in the database. And so that's just kind of how SQL works to find things in a database. And Ted is going to do a small little demo on what this looks like on a broader scope.
All right, so here is a small little SQL demo I have set up here. And let's take a look at what we're doing here. So here we have some SQL that's setting up a little table called accounts. So we're creating a table with two fields, user and password, and we're inserting some values here. So this is just to initialize the database. So we're inserting into this table accounts the values cyber for user and kiwi for password, and then the same for here. So so let me show you a sample, a couple of sample queries for that. So we have a couple queries here that I prepared. So, so here's one that's select user, which is the field that I want to select. So select a user from the table, so accounts, and we're going to limit the results to 1. And then here's another one, which is slightly different. So it's selecting star, which is all the fields. So it would be the same as writing select user and then password from accounts, since those are the only fields. But I'm going to put select star from accounts where, and then we have this where condition, which I've set to look for a user equal to sample user. So let me execute this query and we'll see what we get. So for our first query, for our select user from accounts, we're getting back only the user field because that's what we specified. And we're getting back the first entry because we've limited it to 1. Oops. And then that is cyber. So that makes sense. And then for our other query, we're selecting every field using the star. So let me zoom in. We're using the star, so we're getting back the user and the password field, and we're getting the where condition where user is equal to sample user. So pretty self-explanatory. We get that back here. And then just want to show you another quick little example. So I'm going to uncomment these lines. So just to reinforce, like for those who have never worked with SQL. So we're creating another table called documents, and we're creating a few fields, and we're inserting some values here. So the name is doc1, type is text. This is the content, And we're just doing this a few more times with some other content. Okay. And then we want to look at the query now, and I'm going to uncomment this one. Oops. So these 2 dashes here is a line comment in SQL. So I'm going to remove that. And we're going to show that we have select star, again, all the fields from the table documents, and we're going to limit the results to 2. So let's execute that and see what we get. So as expected, we get 2 results. We get every field, name, type, and content, and we have and we see the results here. So yeah, just a quick introduction to SQL and to show you, kind of get some context behind what you'll be doing for SQL injection. So now let's go to the slides. I'm going to show you what SQL injection is all about. So yeah, I think you guys should be able to see this. Oops. Okay. So what is SQL injection? Well, it's basically injecting our own string into a SQL query. So what does that really mean? So let's look at this example. So this is an example of a regular query, nothing weird going on. It's just replacing, it's putting in the input here. So where username equals, and then my username, because that's what I input, and then my password for the password. Now, how can we put something that messes up SQL or makes SQL do something that it isn't supposed to be doing, or what the developer didn't intend for it to do? So here's one way of SQL injecting, I guess. So so we want to essentially make the where condition for the query always true. So a way we can do that is to kind of trick the SQL interpreter to put an or condition with a true statement. So let's break this down. So here's our input for the username. Instead of putting like our actual username, we're putting this carefully constructed string. And so let's look at what that will translate into. So we have select star from accounts, which is normal, and then the where condition, where username equals. And then here we have, we put an apostrophe here. So the SQL interpreter says, oh, they're ending the statement here. So their username is an empty string or an empty character here. But then the statement continues and it says or 1 equals 1, and 1 equals 1 is true. So um, what this looks like to the backend is just select star from accounts where true. So basically, it's gonna ignore this where because it's always true. So it's gonna return everything that it finds. And then in the end here, we just have a semicolon which ends the statement, and then two hyphens or dashes to comment out the rest of the query, so it's ignored. So it doesn't even check for a password condition once you comment that out. So yeah, so essentially our query becomes select star from accounts. And so what does this actually do once it executes this? Well, let's say for a login, it's set to return one value. So what this is going to do is just it's going to iterate through the accounts table, and it's going to find the first one that returns true for the where condition. And since everything is going to return true, it's just going to give us the first account. So we can log into whatever the first account is on the table in the database without even knowing the username or the password, which is obviously not intended. So that's one way we can use that. So I'm going to break it down even further here really quickly. So the from accounts is telling it to look at the accounts table. The select star is to select the fields. So every field it's going to return. So this select star from accounts is going to be in the back end. So you're not actually typing this. We're just inserting into the username part or the password part, because those are the parts we're able to interact with as a user, as a regular user. So yeah, so here we can see it selects the first entry in this table because we have where username equals blank or true. So basically where the condition is just always true. So it's just going to select whatever it finds first here. And then this rest of the statement is just commented out. So it's ignored. And then here's another technique we can use. So instead of selecting the first entry, let's do something else. Let's do something a bit more complicated here. So so we have this apostrophe and a semicolon. So what that'll do in this translated little box I have here, it's just going to make the username empty, just like the previous example. So we're going to end the statement there. And instead of doing a or true condition, we're going to actually put our own custom query here. So for example, we're going to put this select star from documents and then comment out the rest of the query just like before. So let's say we somehow know one way or another that there is a table that exists called documents, but we can't access it. We're the attacker and we can't access that through normal means. Well, we can use this multi-query and select from the documents table without even having access to it. So being able to execute a arbitrary query is very powerful, and you can cause some. If you find a way to do this on a website, it's very powerful and can be very destructive, because let's say you just put in like delete all the tables, or like that'll just destroy the database. So for our challenges, you actually won't be able to do this, but like if you were, because we're putting it in a read-only state database. However, for a real life scenario, if you it won't be a read-only database in most of in most cases. So you could cause some really major damage by doing that. So let's break this down. Once again, from accounts is just selecting the table. Select star is selecting every field, which is the star, which is the star's meaning. So it's going to select a user and password. And then the where username equals blank is just going to result in nothing. But the interesting part is our custom query. So it's going to see this statement end, and depending on how the backend is set up, it might be set to execute multiple queries. So it's going to look at ours and say, oh, select star from documents. Okay, let's go to the documents table. From documents, let's select star, so every field, and let's not have any where conditions. So it's just going to find like the first one, and then if it's set up to return multiple, it might return all of the entries because there's no limit. And then again, these 2 dashes is a comment in Sql. There's other ways to comment in Sql, but this one is just a line comment. So if you see other ways of commenting out, don't get confused. There's just other ways. So we've seen how Sql injection works, and it doesn't seem too difficult, at least what we've showed. And we've kind of scratched the surface, but the general idea is the same. So it seems kind of easily preventable. However, it is still extremely prevalent. It's commonly on the top 10 OAuth security risks. So it's if you don't know what that is, basically a compilation of the top 10 security risks for the year. So this is the 2017 one. So you see injection is the top security risk or vulnerability. So yeah, injection is not only SQL injection, but that is one of the major players in injection. So how do we prevent it, and how do we lead to a world where injection isn't on this top 10 list? So here's some protections that you can take against injection. I'll go over a few ones quickly. So the first one is a pretty obvious one. It's just data or input sanitization. So instead of interpreting these special characters as part of the SQL statement, let's set up some way to filter them or escape them so that they are just treated as, like, for example, part of this username. So their username literally has an apostrophe in it. It's not closing the statement. Or we can even filter out these characters or ban certain characters to prevent this from happening. And of course, there are different ways to bypass filters, but this is just a common technique, and it's something that's integrated in a lot of modern libraries, whether they do it this way or some of the other ways I'm going to explain. So next is limiting privileges by context. So what does that mean? Well, it means that, for example, the login page should only be able to access the accounts table. It shouldn't be able to access like the documents table, for example, or like any other database. So this doesn't really protect against injection itself, but it kind of limits the damage that an attacker could do if they were able to inject. So they would only be able to access the accounts table and nothing else. So they wouldn't be able to mess with the other stuff. So my last one I'm going to talk about is prepared statements. So this is a really common one where a lot of libraries like have this implemented in some way. So basically, I'm going to show you this example. So it's a statement. We have a statement here where it's what we've seen before, select star from accounts, where username equals. And instead of putting in the username directly, it's going to have this special variable, and it's going to input it in a special way. So the SQL engine kind of checks it over and puts it in so that it's not actually interpreted or treated as part of what's to be executed. It's just a literal string, something of that nature. And so that way we can prevent injections in that way. So those are a few ways to protect against injections. And what if you're not using SQL? Do you still have to think about injections? And yes, you do. And Peter will be going over NoSQL injections in a bit. But first, we're going to have Steph show us a little SQL injection demo, and to get you guys familiar with how that works. So Steph, please take it away.
All right. Okay, so I'm just gonna do a small little SQL injection demo using what we saw in the slides mainly. So as we see here, we have just a simple login page, and from the login page, we are just not logged in. We can't access anything, right? Um, Assuming we don't know what type of database we're dealing with, we'd want to try to figure it out. This is a SQL demo, so we know that it's got to be some type of SQL database. But if we didn't know, one of the ways we could try to figure it out is by trying to force the login page to give us an error. Because if we got an error, we could maybe figure out what type of database we're dealing with. So to do that, I can just put in a single quote and just put in anything into the password field. And that's going to give me a SQLite error. So now I know I'm dealing with a SQL database, specifically because it gave me an error. Now, why did it give me an error? It's because I kind of induced like a bad syntax. Since it is a SQL database, it's gonna have a query sort of that has this format. Sorry, one sec, let me write this out. Where our inputs are just gonna be put into these fields, right? And so if I put a single quote right here in username, it's gonna close off the username field and it's just gonna leave this single quote out, which is bad syntax and it's gonna induce an error. So that's great. Now I know that I'm gonna use SQL queries to access the database. And essentially none of this stuff I can touch. This is all backend. So it doesn't particularly matter what's there because it's already going to try to access an account from the database. It already has a table it's going to go from. But what I can do is modify what username or what user it's trying to find. And to do that, I'm just going to use the or 1 equals 1 SQL injection. Right? And this is going to log me into the website. These two things are going to comment out everything after that. The semicolon is going to mark the end of the query, and username null or 1 equals 1 is going to be something that's always true. So it's just going to pick the first one that's available. So if I go ahead and type that in, and I type anything into the password field, it's going to log me in to the first account, which seems to be an IT account. And now I have, well, access to the website. So that's just a basic way in which to use SQL injections. And now Peter will talk about NoSQL injections.
Awesome. Let's see. Oh, all right, can everyone see the slides? All right, just thumbs up. Okay. So yeah, what is NoSQL, right? Well, I guess before we explain like what NoSQL injection is, it's important to understand sort of the differences. Oh, chat. All right, yeah. Sorry. To understand the differences between a SQL database and a NoSQL database. I think there are three like fundamental components to understanding NoSQL. One, it's a non-relational type of database. Two, it provides horizontal scalability. And three, like the data contained inside the database is unstructured. And so we'll explain, I guess, one by one what each of them mean. So starting with non-relational, I guess, what is non-relational? Well, in a SQL database, things are organized according to fields, rows and columns. Like for example, ID, name, eye color, age. These fields are set, and each entry within the database has to conform to the type and specification outlined by the schema. But in a non-relational database, it's a little bit different. Instead of tables, we have something called a collection, and within those within a collection are documents. And so an example of a document is here. ID, name, color. So similar to fields, except it's there's a little bit of a difference. For example, fields within a document can vary from document to document. So it's not necessary that document 1, for example, shares the exact same fields as document 2. Additionally, what can be contained inside of these fields can vary. They could be strings, they could be integers, they can even be objects themselves. And then the second point of horizontal scalability is that in NoSQL databases are optimized to promote like horizontal scalability versus vertical scalability. And I guess what that means is that instead of having like one machine that processes a lot of the reads and writes, the workload is distributed across parallel machines working in tandem so that they can process multiple reads and writes. And that's useful for like social media applications or applications where multiple users would be wanting to, I guess, upload data or read from the same source of data. And so the third point is like unstructured data. Within a NoSQL database, a lot of the like data within them is not uniform. There's not necessarily a standard that they have to conform to. So an example would be like email, multimedia, documents, even tweets. They're not really organized into a specific format or a specific type. And so having an unstructured data within a NoSQL database allows for more flexibility when analyzing that data. And so having understand, I guess, the 3 points that are important to NoSQL databases. One popular NoSQL database is MongoDB. And so here's some of the syntax of how one would like use, I guess, MongoDB. For example, you could create a collection using db.createCollection, and we'll name the collection posts. And then we can insert documents by referencing that collection using the function .insert. And then within this object, we specify attributes and fields, like so. And as you see, this, for example, would be like an integer type. This would be like sort of like an array, and you can even contain like objects itself right here. And so furthermore, we can use functions like find, right, to query the data from a collection, similar to a select statement in SQL. If we do db.post, right, .find with no arguments passed in, that will return all the entries within that particular collection posts. And so it gives something like this. There will actually be an object ID, which I'll show later in the demo, but I think you get the point. And furthermore, we can use query options, right, to filter query results from a particular collection. So we can use db.post.find, and we can specify this thing here, which is essentially a query operator. And what this is doing is it's looking at the field likes, and then within that we run this particular query operator, which is JavaScript, which means greater than or equal to 5. And so this will display the results, right, in the collection posts where likes is greater than or equal to 5. And so where does NoSQL injection come in? So I guess consider the question what if database queries, included untrusted input? So I guess consider like the server code right here where we have a DB, like a collection name, .find, and we have this where function, right? So essentially what this where function does is it allows, it runs this JavaScript function here, and we just pass in username. So we can actually insert, right, JavaScript into this query. We use db.collection.find where function equals return this.name equals a. So we just put quote a colon sleep. This, because it's within the context of the where function, what will happen is that it will return a or try to return a, but then it might execute sleep. And so because it's interpreted as JavaScript, this could, if you actually formed a more malicious attack, you could perform a denial of service. And I guess another example here is using PHP. So let's say we collected the username and password from a post request, and then we access the collection, right, and use the function find one. And then for the username input, we put this query operator here, right, which is greater than not equal to null. So basically that is, we want to return the entry from the collection where the username is not equal to null and the password is not equal to null. Now, if we assume that in a username password database, there would actually be a value for the username and password, this would actually return the first entry within that particular database and might allow us to log in. And so before I go into protection against NoSQL injection, I'm going to share a little bit of a demo here. So here. Okay, so let's see. I can use start Mongo here. So I'm running Mongo locally. Use DB. And now I'm going to use the collection social media. Or so I can do db.post, or use the database social media. Do db.post, and that's the name of the collection. If I do find one and specify no no arguments, that'll return the first entry. If I do .find, that'll return all entries within that database. As you see, there's an ID, an object ID that specifies, distinguishes the documents from each other, and then we have the arguments and attributes here. So we can do something like db.post.find1, and then we can pass in that query operator. So let's go likes, where I think it's greater than up, greater than equal to 5. I think this is
Bruh.
Oops. Oh, I think I messed up the syntax here.
Bruh. You serious?
Furthermore, we can use something like db.post.find and then specify a query operator. So for example, let's say you want to return the likes or the posts where the likes is greater than or equal to 5. So we can specify that like so. So we can do likes colon and greater than or equal to operator colon 5. And as you see, it returns documents that match that particular filter. And so moving on to the actual demo, let's try to find a way to perform NoSQL injection. So let's assume that we don't know necessarily what the attribute names are. Let's just do a random password here, and we get invalid. If we go to inspect element, and then go to network, then try to log in again, we can see the actual post request. And if we scroll down to form data, we see that this is what we had entered. And the name of the attributes is username and password. So we can assume, or we have some knowledge, we can make a guess that username and password is what the backend is putting our input into if this particular server does not sanitize our inputs. So let's try doing a SQL injection, or NoSQL injection. If we do something like not equals, and then like this, essentially what this will do is, what we want it to do is to return a particular entry where the username and password is not equal to null. So we try to sign in. Oh, and it doesn't work. So if we look actually at the backend code, we see right now I've printed out what the server is receiving. And if we scroll down here, we notice that our inputs have actually been escaped with quotes. So it's being interpreted as a string instead of an object. And because of that, this not equals, this operator doesn't actually get run. So we have to find a way to somehow avoid this strong typing that's occurring. And so we can use a tool like Postman to essentially send raw data to this particular route. And so if I do send here, as you see, it sends the post request and it's asking for fields. And let's specify directly what we want to send to the server. So I can do username right here, and I send the exact same request that we did or tried to do in the form. Here. And if we send this, we see that we actually bypassed the login. And this is the content of the actual web page behind that login. And if we look at the server here, we can also see that our request that comes in is already formatted within a BSON object type right here. Instead of a string, it's not escaped, as you can see. And because of that, when find1 is called right here, it actually uses and evaluates this expression, which returns the first entry in the database, which allows us to log in, and it recognizes it as having valid credentials. So I guess protection against NoSQL injection. There are 3 ways. These are not the only ways to do it. One is to sanitize inputs. So using libraries like content-filter and escaping certain characters such as $sign and brackets. These are good practices as any developer should use to essentially escape NoSQL injection attacks. Oops. A second would be to not use JavaScript ejectable functions with user input. So avoid using where, MapReduce, and group, and sanitizing user input if you're using these particular functions to query a database. And the third is to use strong typing. So essentially what strong typing is, it would be similar to how the form in the demo was forcing like the username and password parameters to be a string. That doesn't necessarily prevent SQL injection, but preventing a user from passing, for example, like an object that can run JavaScript within that context, should probably be prevented. And yeah, thank you for coming.